So translations, reflections, and rotations are all rigid motion. And we're also going to apply some triangle congruence theorems like angle, side, 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 to prove the congruence of a couple of rigid motions. So we have first reviewing what congruency means. So congruency basically means that the shapes, lines, whatever it may be, are equal to each other. So if you're changing the orientation of a figure, if you're flipping it, if you're moving it, like translating it, if you're rotating it, you're not changing the congruency. You are completing those steps, but those steps do not change the actual size of the shape. All right, so the ratios are still exactly the same. All right, the side lengths and side measurements are exactly the same. Just because you translated something doesn't mean that those images aren't congruent, and vice versa. All right, so reviewing what congruency means, we have a few pairs of images. So over here, the hexagons, are these congruent? Are they exactly the same length and same angle measurements? All right, that's another way to think of congruency. So are these two hexagons congruent? All right, no, they might have the same angle measures, but they have different side lengths, so they're not congruent. What about these pentagons? All right, yes, they have both, same lengths and same angle measurements. One is rotated a little bit, but that doesn't change the length or the angle measures. What about these triangles? All right, they are congruent, again, same lengths and angle measures. Are these gears congruent? All right, are they the same length and the same measurements all around? All right, no, they're different sizes, so they can't be congruent. All right, they might be similar potentially, but they're not exactly the same, so they're not congruent. And over here, these two fonts, are they congruent? Yes, they are exactly the same size and shape, so they are congruent. All right, so just reviewing what congruency is. Now, we know that triangles have corresponding parts if they are congruent. So you actually don't have a picture of triangles below, so you're gonna have to fill that in. All right, so draw two triangles, do your best to make them look exactly the same. All right, these are supposed to be congruent. And label them the same way that I am labeling these triangles on the board. So we have triangle ABC, triangle DEF, and we'll put the side lengths as lowercase ABC and DEF. All right, but so label it like that. And what we are trying to tell you with this slide is that congruent triangles have corresponding parts. All right, corresponding meaning the same. All right, so triangle ABC over here is congruent to triangle DEF. right, and order does matter with the way that you're writing these. It can't be like CBA is congruent to DEF. All right, order matters because you're showing that A is corresponding to B. All right, that B is corresponding to B. That C corresponds to F. All right, and then if we were talking about the side length, things like that, then we would say A corresponds to B and going that way. All right. So right here, I would highlight in the text. So do you think there is a minimum number of values needed to prove the two triangles are congruent? All right, the answer to that is that you need at least 3 values to be congruent to prove that they are indeed congruent. All right, so I could give maybe 3 angle measurements and 3 angle measurements here to prove that they're congruent. I could have all the side measurements to prove that they're congruent. As long as I have 3, then I can prove that they're congruent. So the parts do have to match up and the order of the parts does matter. All right, questions? All right, so then on the next part, it says how do parts match up? You learned previously that corresponding parts are the ones that match up with one another. So I'm going to switch slides now. All right, I would highlight that corresponding parts are the ones that match up with one another. All right, so those 2 triangles that we looked at, just kind of picture them on top of each other. That's a good way to think of the corresponding parts. You know that A lined up with D and D lined up with E and so on. And also recall that congruency of parts can be shown by hash marks. So like tiny lines that tell you which is congruent. So like if I was looking at triangles again, if I said these sides are congruent to each other, I could show it by putting 1 hash mark to that same side. All right, if I put 2, like maybe it looks something like this. Now we're saying that these sides are congruent to each other. All right, questions so far? All right, so same number of hash marks on different shapes means that they are congruent. All right, so look at the triangles on the next slide. All right, we have congruency shown by hash marks. So if we're saying that BC is congruent to EF, we're showing that with 1 hash mark there. We can also say like angle B is congruent to angle E because there's 1 hash mark through both of them. So take like 10 seconds and fill in these blanks. All right, even though they're like not shown in the same orientation, it looks like one of them is rotated. Still figure out what parts are corresponding to each other. Which angle corresponds with angle A? I think I heard B. Any disagreements there? All right, since both angles have 2 hash marks going through them, they are corresponding. Good. What angle corresponds with B? So it should be on opposite triangles. Good. All right, corresponding parts will be on each triangle. So the part of the triangles that are the same. All right, what about which angle corresponds with angle C? Good. All right, no hash marks through this one. All right, so they're both the only ones that don't have hash marks. And because we have those three equivalent angles, we can say triangle ABC corresponds to triangle DEF. All right, because we go in order. So by saying triangle DEF, we're showing that D corresponds with A, E corresponds with B, and so on. All right, good. Any questions? All right. So on the next one, we are going to talk about a few different theorems. So first we're going to talk about the hypotenuse leg theorem, or HL theorem. The important parts on all of these are going to be where it says what it says, like right here. So if two right triangles have a congruent hypotenuse and a pair of congruent corresponding sides, then the two triangles are congruent. All right, so look at the example here. We have BC and EF are congruent to each other, which you can tell by the hash marks. And then in order to prove that they're congruent, we just need at least one leg to be labeled. So it could be either this one or this one. Since this leg has one hash mark, and so does this one, we can say that the triangles are congruent. All right, questions? So these are congruent to each other. All right, that's the congruent. Over here is a proof that goes along with this theorem. So a lot of geometry is making these two column proofs to reinforce some theorems that we learned. So if I'm trying to prove that these two triangles are congruent, here's what my proof could look like. We could say BC is congruent to EF, and that's a given, right? It's on the diagram. And given is usually what we start with anyway. We're also given that AB is congruent to DE, also given in the drawing. When we're saying triangle ABC is congruent to triangle DEF, we can put the theorem that we use, which is the HL theorem. And if you want to be more specific, you could write out, you just need the hypotenuse and one leg to be equivalent. All right, but really just writing the titles of the theorem works. Questions? All right. So before we do the first example, I'll let you guys have a 15-minute break. So be back at 12:29. It would probably be best to use side, side, side to prove that these are congruent. All right, because since this is on a coordinate plane, we can figure out the length of each side. Do you remember what formula we used to find that? To find the distance from like A to C. All right, I was trying to give it to you there. We're going to use the distance formula. All right, so let me just remind you what that looks like. The distance formula has a square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. All right, by applying this to each side, we can determine that these are congruent. And it is a little tedious that way, but that's the only real way to prove that they are. So for maybe side AC, that corresponds with side BF. For those ones, it might be easy to count because you can clearly see what's the distance between AC. How many points away? All right, if I'm going from 0 to 2, what's the difference between them? 2. All right, so side AC is easy to read. So is side BF. These other sides are on like a diagonal. So those ones we definitely have to use a distance formula. All right, so for side AB, in order to use a distance formula, we have to identify those points. So what is point A? What's the xy value there? 0, 2, good. The x-axis and the y-axis. What about B? 1, 4. All right. So for side AB, to figure out the distance between those, label one of them as x1, y1, the other as x2, y2, and plug it into your distance formula. All right, so we label it like this. It goes 1 minus 0 squared plus 4 minus 2 squared. And I showed you before that you can enter all of that into your calculator at once. All right, so practice entering that. You'll need to put the square root symbol by hitting the button that says second and then the button that says x squared. You can do the little square root symbol above that button. Yeah, if you don't have a calculator, you need one. So practice plugging that into your calculator. And then keep going for all of the other sides. So like since side A, B, and D, E correspond, what should happen is that after applying the distance formula and finding that measurement, you get the same thing. All right, what do we get for side AB? What measurement do we get? Round it to 2 spaces after the decimal. Right, everyone should be practicing. Don't just wait for me to put the answer up there. I already know how to use the calculator. I'm not going to use it for you on your test. That's all right. Put it in your backpack. Put your backpack over there.
Over there?
Yeah, since you keep putting it in, no matter how many times I tell you. All right, what did we get for the distance between A and B? You got 1? Not 1. Let me see how you're entering it. So you have to put the square root on, and you have to put the parentheses. So it should look exactly like how it looks right here in the calculator. All right, so the second, the blue button that says second is what you need to press. Then the x squared. All right, that'll get you the square root button. There's buttons for parentheses. All right, what did we get for the distance between A and B? If you're rounding it, put at least 2 spaces after. So 2.24. All right, or more exactly, it's the square root of 5. All right, so my distance from A to B is a square root of 5, or about 2.24 is what you're seeing on your screen if you put the whole thing at once. All right, now what did we get for side DE? So hopefully you're working ahead of me and not just writing down what I'm doing. Because you would have to know how to plug it into the formula and then how to plug it into your calculator. right, so once you plug in those coordinates, it should look something like this. What do we get for the length of BC? 2.24, or if we're using the more exact measurements, it's square root of 5, good. What about for side EF? All right, same thing, right? So since we proved that these three corresponding sides all equal each other, then we can say that these are congruent. So this is what our triangles look like right now. I know there's a lot of work there right now. All right, but to write out everything that we just did, we just proved that AC and DF equal to that AB and DE equals square root of 5. That BC and EF also equal the square root of 5. Therefore, triangle ABC is congruent to triangle DEF by SSS, by side, side, side. So by having three corresponding sides all equal the same thing, then we can say that it is congruent. All right, so this is kind of like our summary. So make sure you have this part. That is how we prove that they are congruent by side, side, side. All right, so that method is a little more tedious if you have to find the distance formula for all the sides, like we just had to do. You will have distance formula on your quiz, so I'm not gonna lie, that was a little painful watching only a few people try it out on their papers, but I just know once we get to the quiz, it's gonna be a struggle. So make sure we're practicing putting them in the calculator and putting them into the formula, not just copying what I'm writing. All right, so next one, example 2. We're going to prove that these triangles are congruent, and you guys are actually going to prove it on your own paper, so you try problem. You will have to use the distance formula. So here it is in case you need a reminder. So x2 minus x1 squared plus y2 minus y1 squared. All right. So prove that these are congruent by using the side, side, side theorem. All right, so label the distances for all of the sides to prove that they are congruent. I'll give you about 4 minutes for that. All right, so let's just take a second and label all the points. So point C should be labeled as what? -5, 0. What about point B? -3, 4. And point A is -2, 1. This other triangle, I'll put in a different color. Point S should be, point E should be 1, 4, and point B should be 2, 1. All right, hopefully that was the easy part. If you're struggling with that, and maybe you're just too scared to ask, you don't have to ask me in front of everyone. You can ask me when we're just doing independent work. All right, any of these labeled incorrectly will throw off your distance formula. Even I label them wrong sometimes, and then I check the answer and I'm like, why doesn't it match up? All right, so labeling them correctly is the first step. Then to prove my side theory, I need to prove that the corresponding sides are the same distance from each other. So like, I need to prove that these purple sides, BC and BF, are the same. Did we get a value for that? All right, what does side BC equal? Um, 4.47 is correct. All right, so if you rounded it, it should have been about 4.47. All right, for those sides, just to show you what that looks like. So let's say we're doing side BC. All right, plugging it into the formula, we have -5 minus -3 squared. Right, x minus x, and then y minus y. So 0 minus 4 squared. All right, putting it all into the calculator at once gives you that 4.47, and it continues, but rounded is about 4.47. And they're exactly the same for side BC and for side EF. All right, I'll save you the trouble of that one, and we'll just say that the distance is also 4.47 because it is. All right, now what about for side AB and side DE? Did they equal the same measurement? All right, what did we get for those measurements? So about 3.16. All right, I know Brianna understands it. I'm not sure about everyone else. Right? Make sure that we're not just being lazy and not entering things into the calculator. All right, that's the sense I'm getting, that it's too hard, so you're just not going to try. All right, in the calculator, it should have looked something like this. There is one other way to put it in. But for side AB, it should have been -3 minus 1. Oh, wait, I'm looking at -3 minus -2 plus 4 minus 1. All right, and then squares outside these things. All right, so x minus x, y minus y, plugged into the formula. You get the square root of 10, or rounded is about 3.16. All right, same with side DE. All right, x minus x, so 1 minus 2 squared, plus y minus y, so plus 4 minus 1 squared. All right, again, we get the square root of 10 or 3.16. All right, making sense? Good so far? All right, to prove it by side, you need to know the length of the last side. So side AC and side EF. All right, what did we get for those lengths? .16. All right, that is correct. And since they both equal the same thing, then we can put them as equivalent to each other. All right, and I would show you, but given that I saw people not really taking notes, I'll just kind of move on. All right, questions? All right, so since all of these sides that are corresponding do equal the same amounts, we can say that they are congruent by side. So down here for like your summary, you can write side AB is congruent to what side? All right, it's congruent to side DE. We have side BC congruent to what side? Right, it's congruent to side EF. We have side AC congruent to side DF. All right, and because those are three corresponding sides that are congruent, triangle ABC is congruent to triangle DEF by side. All right. So these symbols, make sure you know how to read them. You'll see them on your quiz. Any questions? All right. So example 2. So we're not even a little bit done. Sorry. Those ones took way longer than they needed to be. All right. So determine if these two triangles are congruent. And this time we have other things that are labeled, or at least one thing that's labeled, and that's these two angles right here. So angle B corresponds to angle E because they're congruent to each other. They equal the same thing. Because we have that little bit of information, that angle B is congruent to angle E, instead of finding all of the side lengths to prove it by side, we can prove it by side angle side. All right. So even though we could use side angle side, things like that, since we already have at least one angle, we'll do it by side angle side. So with that, we have to identify what sides we need to find the distance of, because it's not just any two sides. Since it goes SAS, we need to find the sides that are touching the angle. All right, so I need to find side AB On the other triangle, what side matches side AB? Good. So I need to find those two sides. And then I need to find the other side that touches that angle. So side BC, what is the corresponding side on the other side? EF. Good. All right, that is what I am going to find. I don't worry about this bottom one because it's SAS, it has to be side, angle side to prove that theorem. Make sense? All right, so we don't have to use the distance formula we don't have to use it 6 times like the last 2 problems, we have to use it 4 times. So still practice with the distance formula. All right, so do it for side AB. And then again for side DE. Then once you've found that, you'll find it for side BC, and then for side EF. All right, I'll put the distance formula down here. I really need you guys to practice. Even if you get it wrong, that's all right. All right, I'll help you out if I see you wrong. All right, so I have some of the work shown out on the board here. So you can compare it to mine. You could have had them a little bit different than what I have here, but if you did it right for side AB and side DE, then you should have had about 3.16 for each of those sides. All right, if you did not get that, call me over and I will look over what you entered on your calculator. All right, but that's what it should have been if you rounded it. Good. All right, I know I normally tell you to like label them X1, Y1 so that you don't get confused. But as you keep going through this, you kind of just notice it's always X minus X in one set of parentheses and then Y minus Y. All right, that's kind of like how I wrote them here. I didn't do as much labeling as I have before. Good. What did we get for the side lengths for B, C, and E, F? All right, good, it is 5. All right, I can show you the work here in just a second, but they both are equal to each other, and they both happen to equal a whole number, which is 5. All right, so again, plugging it into your distance formula. For BC, it's going to be x minus x. So over here, this point is 0, 0. Right, so it's going to be -3 minus 0 squared plus y minus y. So plus 4 minus 0 squared. Enter that in the calculator, and that's how you get 5. For side EF, it's really similar. It's x minus x, so 3 minus 0 squared plus y minus y, so 4 minus 0 squared. All right, questions, comments? All right, so really all you guys have to be doing is plugging them in and putting it in your calculator. Only mistakes should be from either plugging them in or using the calculator. All right, and because we have these sides equaling each other, so let's put our little summary down here. Because we have side AB congruent to side EE, and side BC congruent to side EF, and angle B congruent to angle E, then triangle ABC is congruent to triangle DES by side angle side. All right, so put the 3 things that you had to do in order to prove that. So you had to prove that 2 sides were equal and 1 angle was equal on both triangles. To prove that they are congruent, and then you have to put what theorem you use. So since we have 2 sides and 1 angle, it's side angle side. Questions? All right, so just one you try on the next page. I was gonna let you guys go on break around 129, but I think I'll do that to like 125, regardless if you finish that you try or not. If you finish the you try, I will look at it and then you can go a little earlier. All right, but regardless, I'll send everyone out around 125 for another break. So since we have 1 angle labeled for us, we can prove it by side equal side. All right, also because it's on a coordinate plane, so we can use the distance formula to find the side measurements that are near the angle. All right, to really use the theorem appropriately, the SAS one, it has to be the sides that are like touching the angle that it's at. All right, because that's what the theorem says. If these sides match up and it makes the same angle, then the other side would obviously have to match up as well, and the whole thing's correct. All right, so if you found side AC and DF instead, just make sure, like make a note to yourself that it has to be the sides that are touching the angle if you're using that theorem. All right, but what you should have found is when you plugged it in, so I showed you just A, B, and D, E. When you plugged it in, it should have looked something like this. You might have it a little bit different, but if you did it right, you would have gotten about 2.24. All right? So I know, like, as long as you put x1, y1 on one of them, it doesn't matter which one, you'll be fine for the other ones. Questions about side AB and DE? Good on that? Right, if you use distance formula on BC and EF, that's perfectly fine. You should have gotten 3. But you also could have just counted for this one. All right, whenever it's like a straight vertical line or a straight like horizontal line, like no slope at all, you can just count it. So just like how I did here, I just counted 1, 2, 3 and called it a day. All right, so I have side, angle, side, the same on each corresponding triangle, so they're congruent by SAS. Questions? All right. What's even better than that is if you have 2 angles that are labeled, like in this next example, because then I only need to find one side length. All right. So in this case, for example 3, I could use SSS, side, 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 angle, side, or angle, side, angle. All right, but then again, like I said, since we have 2 angles that are pointed out for us, I'm going to use the one that has 2 angles involved because then it'll be a little bit easier on myself. Less distance formula. All right, so for this one, it needs to be the side that is in between the angles. Notice how the S is in between the A's. So the side that we're going to be measuring to see if they're corresponding or not is going to be these sides. So D, E, and AB. All right. Use the distance formula for those sides. Here's a distance formula for your reference. All right, use the distance formula. And then if you prove that those are congruent, then you can stop there because the other 2 sides are unrelated. So we'll do the side DE with the distance formula and side AB with the distance formula. All right, try that on your paper for about a minute. Hopefully it's getting faster for you. All right, I'm gonna freeze my screen now so that you can practice putting it in the distance formula. Have had the square root of 2 or about 1.41. All right, for both sides. Good, any questions there? All right, and that's the only side that we needed to find to prove it by angle, side, angle. All right, to like summarize our work, we can say angle E is congruent to what angle on the other triangle or point E? B, good. We can say angle D is congruent to what angle? Angle A. We can say that side BE is congruent to what side? AB, good. All right. And because we've proven all of those things, so these first two are given, the last one we proved with the distance formula, we can say triangle DEF is congruent to triangle ABC by angle side angle. All right, questions? All right, a little side note, just in case you see it on your quiz. If you see where it says angle ADC is congruent to angle DEF, so it has like multiple angles like that. When it's written in that format, it's focusing on the middle angle. So that's the same as what we wrote up here. That angle E is congruent to angle B. So don't get confused by that. When it says it like this, it's saying basically it goes A, B, C, right? So the B matches angle E and stuff like that. Questions? All right. We will look at this next U try, just because I'm going to save you some trouble a little bit. We're going to look at it together. This U try, notice that we have the two angles, right? So what theorem can we use? Angle side angle, that'll probably be the best one, the easiest one. So we need to find the side lengths that are between the angles. All right, so what side lengths do I need to find? So like on this first triangle, I would find side DE, because that's between the two angles. What other side do I need to find on the other triangle? All right, exactly. And then like I mentioned before briefly, if you have a vertical line and a horizontal line, so not like any slope or anything like that, what can you do? All right, you can just count the distance when it's straight up and down or completely horizontal. You can just count it. All right, and save you the trouble of the distance formula. So what's the distance from B to E? 2. What's the distance from A to B? Are these triangles congruent? Yes. All right, and then, you know, you would label the corresponding ones, label that these sides are equal, and call it a day. All right, questions, comments? All right, so then you have that practice that I passed out. It's a 2.05 rigid motion. I'll set aside 15 minutes of class time. Like until 2:08. And then we'll probably just start 3.01. We're supposed to do 2 lessons today, and we only got 1. All right, so I'll set aside some time for the practice. This one's a Google form. So once you finish that practice, you'll upload your answers to the Google form, and that's what I'll give you points. Questions? All right, we already did it. That's fine. Just make sure you upload your answers. And maybe we'll look at the 3.01.